Hi, year 11 method. So this lesson we are going to learn and it most likely is just review on trigonometry equations. Okay, and trigonometry equations which we have learned in year 10, I suppose. But in year 10 extension course, we used degrees for the angles. Right now, we need to use radian. To start with, if you can remember, that's one very important idea for trigonometry equation. Trigonometry equation can have more than one solution. Most likely, it must be more than one solution. Why? Because there's a periodic nature. Okay, we all understand periodic nature because all trigonometry functions will have its own period. Right now, we are learning sine curve and the cosine curve. Both have period equal 2 pi or 360 degree, right? So, for example, if you are going to find x such that sine x equals half, then you can find two solutions. There should be s here, sorry. For x belongs to 0 and 2 pi. That means x between 0 and 2 pi. So that's the most typical domain for x. Just 0 to 2 pi. That means one turn on that unit circle. All right. So let's see where are the x so that sine x equals half. Remember, on that circle, sine x means the second value, okay, the second value of the coordinates. The first coordinates for cosine, remember that? So let's find how many second coordinate means the y coordinates being half. Here's the first one. For this one, what would be the x? X means the angle, all right? So we want to understand the unknown in trigonometry function. It must be an angle. So what would be the angle for sine x equals half? So the angle x should be 30 degree. But wait a minute, right now we're using radian, so should be pi over 6. So pi over 6 is one of the answers. Where is the other answer? So remember that's 1/2 is the y coordinates. So if you go to the other side of the quadrant, then you will see another half here. For that half, where is the angle? Okay, so the angle here is 150 because you can consider the angle rotate from 0 to 150 like that. Okay, so that means the other angle is 150. But again, we're not going to use 150. We're going to use 5 pi over 6. Okay, so how do we know what's the feature for these two? What's the common thing for these two angles? So you can see there's at least one common thing for both angles. The reference angle must be 30 degree. Of course, the reference angle for 30 degree is 30 degree. How about the reference angle for that 150 degree is also 30 degree, right? So I redraw the angle for 150 degree, and here is the reference angle. Just a quick revision of the ideal reference angle. So both angles are of reference angle 30 degree. This is a very important fact. Right. So let's go to another example for cosine. This time I give you a negative thing. For cosine x equals a negative half rather than positive half. Again, there should be two solutions for x between 0 and 2 pi. Where are they? For cosine x, you need to look for the first coordinate rather than the second coordinate, right? And the first coordinate being minus half, would that be in first quadrant? Of course not. Or the first coordinate in first quadrant must be positive. So then let's go to the second quadrant. Then you will see a negative half here. So that negative half is for cosine. But what's the angle? So that negative half belongs to 120 degree, or 2 pi over 3. Okay, so 2 pi over 3 is one of the solutions. Can we find another solution? When you go around to the third quadrant, then you can see another negative half. And for that angle, this is 240 or 4 pi over 3. So we write 4 pi over 3 here. So now you see that two solutions for cosine x equals minus half. So again, what's the common thing for these two angles? And you can see for both angles, for example, 2 pi over 3 or 120 degree, here's the angle, right? But how about its reference angle? So its reference angle is being here. So that's the reference angle for 2 pi over 3 or 120 degree. And that reference angle is 60 degree. Okay. And how about the other one? So for the other one, I use another color. If I draw the angle all the way up to here, so that's green angle from 0 to here is 240 degree. But the reference angle, 240 degree minus 180, still 60 degree. So both angles, they must have the same reference angle. Then you will ask, then why not like a 300 degree? Because the reference angle is also 60 degree. Okay, but for 300 degree, you see the first coordinate for cosine x is half, which is not minus half. But it's close, but it's not the same. So for cosine x being negative, you need to track whether they are in the proper quadrant, because if we still remember, add sugar to coffee. If you need to find cosine being negative, then you need to go to S quadrant or T quadrant, which means second quadrant and the third quadrant. And for sine being positive, you need to go for the first quadrant and also the second quadrant, which is obvious. What's the conclusion here? The conclusion means there are two things we need to consider when we are looking for the solution for sine or cosine functions. One is the reference angle, the other is which quadrant. As usual, we're not going to do, because of that the time constraint, we're not going to do tangent. And sorry, we don't really have time to do that little interesting question. If you are really interested to know the answer, you can go to my PowerPoint on the OneNote. Let's move on to example 1. First, I'm going to demonstrate some paper 1 questions. In paper 1 question, you can't rely on your calculator. So you need to be pretty good at drawing those special triangles and getting the length of sides. And you don't want to forget there are 4 steps for you to find the solutions. Let's try to do it step by step. For A, 2 sine x plus 1 equals 0. First of all, you need to write that equation into a format like a sine ratio equals a number. So I will try to move the numbers to the other side. For example, I'm going to move that 1 to the other side, becomes -1. Then I'm going to move that 2. Let me try to magnify it a little bit, zoom in a little bit. All right, so we all know if I move that, it becomes minus half. All right. Then what will be our next step? Okay, step 1 is done. It's a Trigo ratio in sine x equals minus half. Step 2, find the reference angle using trigonometry function in the equation. So what will be the reference angle for that minus half? First of all, remember that reference angle always need to be an acute angle, like those 60s. So when we are looking for the reference angle, you don't need to worry about that negative sign. Let me repeat that, which is very important. You don't need to worry about the negative sign in front of half at this stage. Just focus on the numerical part first, which is half. So you need to ask yourself a question here. What would be the angle such that it equals, what angle for sine equals half, not minus half, just half, okay? And at the moment, you don't need to worry about the negative sign. So in the previous lessons, we've learned how can we find the values for sine 30, 45 degree and sine 60 degree. But right now, it's the reverse process. It's the reverse process to find an angle such that sine is half. So it's a difference. But to do so, you still need to apply similar thing. Some of you might be very smart. You say, oh, I know, because sine, we've just checked that's for sine power 6 or 30 equals half. Yes, you are right. But remember, you are not going to memorize these circles for your exam. It's just for the convenience. For my teaching, I like to use it to show you the pattern, the symmetrical property of those trigonometry ratios. What I'm going to do now is to try to simulate a situation in the exam. So you can't memorize that circle. So how can we do it without calculator? Okay, remember, I still need to draw the triangle. Which triangle is going to be relevant? Must be this one, right? Remember that. So if you have drawn it more than how many times? I've said 10 times. Then you start um, memorizing this. But you might still forget. You might still forget, or you might still make mistake on those numbers. But if you have repeated this triangle for 100 times, even in your dream, you draw it right. Okay, so the process is you draw a vertical line here, you cut it into half. Remember this? And that opposite side is square root 3, and our 30 degrees is just here because it cut into half. So how can we get 1/2? So it's 1, it's 2 here. So 1/2 is opposite side divided by hypotenuse for that side, for that 30 degree. So then you know, oh, sine 30 equals 1/2, which is good. Okay, let's go back here. So I know the reference angle is 30. So what should I do? So that's our step 2. You are going to rewrite the above equation into the form of sine x equals minus sine 30. You see, I'm still using degree because we're more familiar with degree rather than radian, aren't we? So we try to use degree as long as possible until the final step. That's my strategy. If you don't like it, you can use radian from start. Sine x equals minus sine 30. So at least I know the reference angle. So I've got the reference angle. So let's go back to, sorry. Right now it's step 3. Find the solution using ASTC. What do we mean by AS? Add sugar to coffee. So right now it's the quadrant. Which quadrant that 30-degree reference angle will become negative? Okay, so sine being negative, which 2 quadrant? So that's our step 3. 4 quadrants, add sugar to coffee. For sine being negative, it must be in the quadrant of 3rd quadrant and 4th quadrant. Okay. So let's try to draw our first angle. So it's 30 here. And also another 30 here. For the first 30, which is in the 3rd quadrant, what would be the angle? So that would be our first solution. This solution would be from here, from 0 to here. So, which is quite obviously the which is 180 plus 30, right? So let's say 130, 30. So that becomes 210. How about the other one? So I have to use another color. So the other one is here for this one. I'm going to rotate all my way until here. So that's from 0 to 30 degree to 360, right? So that means this angle should be 360 minus 30 degree. So the other one should be 360 degree minus 30 degree, which is 330 degree. Are we finished? Very close, but not yet. Why? Remember, when they give you the domain is in radian. If the domain is in radian, then your answer must be in radian. So that would be our last step, step 4. All right, so step 4, you need to express your answers in terms of radian. So x equals, so 210 is about 30. How many 30 there? 730, 7 times 30. But each 30 is power of 6. So that should be 7 times power of 6. How about 330 degree? So how many 30 degree? That should be 1130 degree. Each 30 degree is power of 6. Remember, power of 6, pi is 180 divided by 6 is 30 degree. And there are 11 of them, so 11 pi over 6. Remember, that's paper 1, so you can't use your calculator. So you have to be very familiar with those special values. For example, when we're talking about 30 degree, then you know, oh, 30 degree should be power of 6, 180 degree over 6, so that means power of 6. Then from 30 degree, you think about 220, 330, etc. All right, so that's how can we get the answer. Let me repeat quickly. What are the steps? Step 1, you need to see the trigonometry equation in the form of a sine or cosine something equals a number. And then you need to find the reference angle for that, the numerical of that number without considering the negative sign at that stage. You draw those triangles. Good. Third step depends on, according to, the sign of the trigonometry function and the nature of that function, you need to decide which quadrant are you going to find, are you going to locate the reference angle. In that case, because sine is negative, so you're going to use the third quadrant and fourth quadrant. And the last one, and you have to convert that into radian. That be good? Okay, so I'll give you some time to copy it and a little bit time for you to digest. I need to take a break as well. Okay, so I'll give you, how about 3 minutes to tidy up. Let's continue. Let's try to do part B. Part B, step 1, rewrite the equation into trigo ratio equals a number. So let me just write that as step 1. 2 cos x minus square root 2 equals 0. So I'm going to put that square root 2 to the other side, and cos x equals square root 2 over 2. So first step is pretty good. Second step, still remember what I'm going to do. You are going to find a reference angle for the numerical part of the trigonometry equation, which is square root 2 over 2. All right, so you're going to think about, before step 2, what value for cosine will make it square root 2 over 2. Still remember the triangle here. Can we use this triangle? Can we see square root 2 there? we see 2 and square root 3, but no square root 2. That means we can't use that triangle. So we need to have another triangle. How about that one? So there are only 2 special triangles. One is equilateral triangles with length 2, the one we did before. The other is this one. For that one, you see 45 degree and 90 degree. That's an isosceles triangle, right angle triangle, I should say. So I put these 2 sides, both 1, and then the hypotenuse, square root 2. Can we see square root 2 over 2? No, we can't. But we actually will know that without rationalization, that square root 2 over 2 actually equals 1 over square root 2. Can you see that? Because in year 10, we learned that if you multiply square root 2 on that 1 over square root 2, then you go back to square root 2 over 2. So instead of looking for square root 2 over 2, you can look for 1 over square root 2. So 1 over square root 2. So we need cosine. So cosine means you need to have an adjacent side divided by hypotenuse, adjacent side, and divided by hypotenuse, and that looks like 1 over square root 2 for 45 degree. Okay, so we have cos 45 degree here equals 1 over square root 2, which equals square root 2 over 2. From the above equation, right now we can write cosine x actually equals cosine 45 degree. But does it mean x equals 45? Yes and no, because of course 45 degrees is one of the answers, but it's not all the answers. So that's why we need to do step 3. You need to look for the quadrants. Okay. Right now it's cosine and it's positive. So let me draw the quadrants. You need to be positive for cosine. Which 2 quadrants? Is 2. And you need their reference angle being 45. 45 here. 45 here. Okay. For the first one, I mean the 45 degree in the first quadrant. Okay. The angle itself would just be 45 degree. No surprise. How about the other one? In the fourth quadrant, let me try to draw it. For the fourth quadrant for this one, for this one, we need to rotate from here to here. So it's 45 degree to 360, right? So for that one, I'm going to use 360 degree minus 45 degree. And this one actually equals 315 degree. A little bit math computation you need to do. The fourth step, you need to convert them into radian, okay? You need to do your homework. So what would be the 45 degree? It must be 180 divided by 4. So that's pi over 4. If you are still very unfamiliar with those pi over 4 equal 45, you just need to practice a lot more times before you can just get the answers quickly. You don't really have the time for you to think too much in the exam. How about the other one? 315 degree. So that one should be 7 times of 45 degree. And 45 degrees pi over 4. So that one's with 7 pi over 4, 7 times of pi over 4. So it's done. I'm going to give you some time to digest another question. Make sure you understand. If you have any steps you don't understand, you ask the one who understands to show you how it is. Good. Remember to make sure, remember you need to make sure you really understand what I'm doing here. This will be definitely part of the exam. That's why you really need to know them. Okay. There are more questions here. Of course, I will get you some time. Oh, before that, sorry. Oh, yeah. We don't need to do tangent. We don't need to do tangent here. I'll give you some time. Try to finish those paper 1 question before I move on to paper 2 questions. Because paper 2 question would be much quicker. But I don't want you to memorize too much things in just one lesson. We've already spent like nearly 40 minutes on a couple examples. All these examples you need to do painstakingly, and you need to make a lot of mistakes until you really know how, already understand how to do it. And you need to repeat before you become really familiar with those numbers, like pi over 4 equals 45 degrees. Can I get you try to do the example 2 part A and part B by yourself? And then we, like after 10 minutes, if time allows, then I'm going to show you the answer. Please pause the video now, and I'm coming back after 10 minutes. Okay. Just show you very quickly for part A, sine x equals square root 3 over 2. If you draw the proper triangle, square root 3 over 2 should have a reference angle 60 degrees. And we know you need to have 60 degrees in first quadrant and second quadrant, because this time sine is positive. So this will be the 2 angles then. For the first quadrant, it's just 60 degrees, but for the second quadrant, become 180 minus 60 degrees. And that's step 4. You need to convert them into, oh, can't see it. So that would be pi over 3 and 2 pi over 3. I repeat, one answer is pi over 3, the other is, okay, can I get rid of it? No, I can't, sorry. Oh, yeah, here it is, sorry, 2 pi over 3. The second one, step 1, 2 cos x plus 1 equals 0, 2 cos x equals minus 1, obvious. Step 2, cos x equals minus cos 60 degree, and of course you need that triangle again. And which quadrant? Cosine being negative, it must be second and third. And second quadrant should be 120 degree. Third quadrant should be 180 plus 60 to be 240 degree. So one is 180 degree minus 60, the other 180 plus 60 degree. And that would be 120 degree or 240 degree, converting them into radian. Okay, so if you got all these 2 questions correct within 10 minutes, you don't need to worry about your exam too much for this part. If you're not, you get half of them correct. It's a good progress as well. So you can just build on that progress. I hope at least you got something right here, because there are too much things we put together. It's very difficult, I have to say. But the good news is that's the most difficult part you will see in terms of the computation, in terms of um, the understanding of the quadrants, and also that those two special triangles, all in paper one, is, and also the conversion into radian sometimes could be tricky. And if you did that correctly, you should be proud of yourself. Okay, that's what I can do at the moment. Okay, here are the answers. All right, let me go back here. So I'm not going to do example 3, example 4. I will leave that to next week. Hopefully I've recovered, so we can do it all together. And yeah, there are a couple more, but we might not be able to do that. All right, and so you see that, oh, it's tricky to see things like this. All right. So 0 to 4 pi, we haven't really learned 0 to 2 pi. 0 to 360, 0 to 2 pi. I might get you to do question 4 and question 5. Oh no, just question 4 possibly. Okay, that's it. Just try question 4 at home. If you still have some time, you can do it in the class. That's it. Thanks for watching the video, and thanks for the teacher to help us run the video, and also post the video for you guys to do your own work. Thank you very much. Much appreciated. Take care and see you next week. Bye.